Preparing. All right, so this is lesson 2A.3.3, graphing polynomial functions, part 2, and we're going to look into the vortex of that, not that. We're going to look at this first. Ah, dang it. That's okay. I want everyone to look at this set of this polynomial that's in factored form for a quadratic. So with factored form in the quadratic, remember we have two expressions. We make them equal to 0. And who could tell me as far as roots go, if I make these two expressions equal to 0, what am I able to find out? You guys remember this? Yes.
The X-Intercepts.
The X-Intercepts, right? The X-Intercepts. And who can look at this and tell me where I'm going to find my X-Intercepts? We have x minus 2 and x plus 3. So where am I going to find my X-Intercepts? Good. We're going to find it at, let's see if we, I heard a bunch of different answers. So let's see, the big reveal, boom. And you can click on the points, remember with Desmos, to see the actual coordinate of it. So we have one x-intercept at -3. And I looked that came from x plus 3 though. Here we have one at 2, and that came from x minus 2. So when you're finding the roots, remember that it's important to note that if we had x minus 2, x plus 3, we're doing each of them equal to 0 to see what our roots are. You guys remember this from last year? Yeah? You set them equal to 0. In essence, this is f of x is equal to these expressions. So you're setting f of x, your y value, you're setting your y value to 0 to see where your points are at y is equal to 0. So we then go through, and this may be really apparent to some of you. X is 2 for an intercept, minus 3, x is -3. So the key is, if you're given the root and you have to put it into an expression, you have to remember that we're going to change the sign. It's like going backwards. You're given this root, x is -2. You have to go backwards to get into the root, and it's x plus 3. We see that direction? I think when you were solving these last year, it was pretty easy to go from the expression to the root. So just remember, the one thing that's a little tricky for today is that we need to know, if we have a root of -3, x plus 3 is the expression we're going to have. Okay. That's just like a little intro. And close this up now, open this up. So all that's going to come in handy because what we're going to do is we're going to graph this equation and we're going to end up with 3 expressions. And why do I know that it's going to be 3 expressions? Aaron? Yeah. Because the exponent is to the 3rd power, I know I can have three roots. We look back to what we studied last week, and it was whatever your value for n is, that's the maximum number of roots that you can have. Okay, real roots. So looking here, we need a process where we can go from here to here. Okay, that's what we're going to learn today. Everything we practiced last week, synthetic division, the X method yesterday, and factoring, is going to make this the steps you already know. So I've set you up with the steps along the way. Now, looking at this, we're going to start by, we're looking at, for all the roots, one of the roots is -3. So I'm going to use synthetic division first off, put -3 here, and what I'll find, I'm going to call it, if you have a root, you're going to end up with 0 remainders. Because if it's a pure root, it's really thinking, well, if I have 24 divided by 6, right? 24. You get 0 for your remainder because 4 goes into it cleanly. It goes into it as a whole number, right? Same idea here when we put in a root of -3 to our expression. We're going to get a remainder of 0. Okay, remainder of 0. You can also think of it as I plug in -3 here. If it equals 0, that's saying that my f of x, my y value, is at 0. So that is another way to look at how we're going to find our roots. But let's just go with what we've already learned here. So first off, are there any terms missing in my expression? Any terms? No, we have all our terms. So what should I put in for my first coefficient in here? 1, then what? Okay, we know to do this, so I'm going to knock it out, drop that, multiply, add, multiply, add, multiply, 0. So I know, first off, I know that -3 is a root, and it better be a root if the problem says it's a root. So that wasn't really a surprise. the next step will be when you don't know what the root is, how to find your first root. But now we're given a root. So watch what we're going to do. What I just figured out was, I know one of my roots is x. One of my roots is -3, so I rewrote it as x plus 3. Then I looked at this, and this is called our depressed polynomial. It's on the bottom. Okay, it's just this set of coefficients that we have to re-express as a polynomial. So how would I express these coefficients as a polynomial? There's 3 of them. There's no missing places. I know my -6 is my constant. What do you think these are? Right? You can always double check yourself by looking back. Looking backwards, seeing -6, 1x, 1x squared. There would have to be a 0 in here for us to skip a term. That's what we're going to go with. So watch what we just did. Really what we did was we had the root of -3, and that depressed polynomial is the second step of it. Second step. So essentially what we did was we divided. Really what we did, synthetic division, we took the expression and we divided by -3. We divided by -3. Or in essence, no, we'll leave it at that. Here's the depressed polynomial. There are no remainders, so this is how it breaks evenly. That's why I put it here. And then what am I going to do to get to my final step of 3 different expressions? What's the last step for this? Factor it. X method. We did that yesterday. You felt pretty good with that, I think. So X method. -6, 1. What am I going to go with that? What do you see? So what multiplies to give us -6, adds to give us 1. I'm actually going to go with 3 -2. Now this is key. This is a +3 and a -2, right? +3 and a -2. I changed this to x plus 3 because it came from a root. But when we use the x method or we're doing anything outside of, we're told it's a root, we just take those exact values and transfer it over. So this is going to be x plus 3 and x minus 2. This was x plus 3 as well. That just came down. This factored, that just came down. Now this last line here, what do you see? What do you see? Is there something weird or redundant? What's redundant? Okay, so these are called multiplicities. Multiplicity. Multiplicity is just when it's the same thing. Okay. So if somebody asks me, hey, how many roots did you have in there? How many roots? 2 roots. 2 roots. But x plus 3 is a multiplicity. So there are 2 values for 3 given. So when we're looking at this in our next steps, we really want to first look at your root if you're given the root. Synthetic divide from the polynomial. Your depressed polynomial is what is left over along with your root. X method that. This just went down. This one just went down. This one X methoded to get down there. X method. So with this, when you're given the root, it's pretty straightforward. The second thing we have to face, oh, and it's up here too, but I just did it all right there. This is not anything different. And this was just stating what the roots are. So let's state what the roots are. Roots. X is equal to 2. X is equal to -3. That would be my answer if I was asked for the roots. They may want you just to factor it down. Okay. For this next bit, I'm going to give you the hints. So the hints for this, we want to look at for number 8 when we get to that. For number 8, over there. It works. For number 8, the complex conjugate. Just remember this. The complex conjugate theorem states this. If A plus BI is a root, then its complex conjugate is also a root. Every single time. Every single time that happens. Okay. The reason being is if we're multiplying two complex numbers together, we get rid of all the imaginary numbers, which is part of the process when we're trying to factor it. So just remember, if one of my roots is a complex number, then the complex conjugate is automatically another root. It's more important for number 8. That's where you'll see it, just warning you. The other one is the possible roots of this function may be the factors of the constant. So we're going to look to that constant to see what our factors are. So how about this? Help me out with this. Let's go ahead and use FOIL and just do this real easy one. Well, let's make this 3. 2 and 3. There we go. All right. First, x squared, outer, inner, plus 5x, last, plus 6. Okay. Now, the reason we look at the last constant, as we do here in a more complex, higher degree polynomial, is because whatever values I have in here, they have to multiply to give us that constant in some form, right? We don't know exactly what it is. This could have been 1 and 6 to get that 6. It could have been -2 and -3 to get that 6. But when we're trying to figure out the roots, where we're going to start to look is really the constant and what are my multiples of that. To get 3, we can do 3 times 1. We can also do -3 times -1. And then it's kind of, are you feeling lucky? Okay. You got to choose one of those, one of the 4. You try it out, synthetic divide. If you get a 0 as a remainder, you know it's a root. That's it. Okay. We'll do a problem like that over here. So don't worry if the hint isn't kind of sinking in yet. So let's look at this. Bring it back. All right, so for number 2 here, we're just given the equation. We just need to factor that. We need to factor it. We don't know the root. For the classwork, when you get to classwork, I think it's numbers 1 through 5, they put a semicolon, and then they give you the root. But we don't have that. We don't have that for here. It's not 4. Definitely not 4. But from our hint, where are we going to look? Where are we going to look to get an idea of what to try out first? Where should I look?
-10.
-10. I'm going to look at the -10 and say, well, how do I get -10? What times what will give me -10? 2 times -5? -2 times 5. 10, -1. -10, 1. There's 4 up there. It's not bad. This isn't a bad number. To get 64, it'll take a while. Last synthetic division. Unless you're lucky. Who's lucky in here? Who's lucky? Lincoln's lucky. Pick a number. Just 5. I'm going to try that one out. I'm going to go ahead and do 5, 6, 3, -10. Why did I just put those numbers? Because nothing's what? Nothing's missing. Our terms go 3, 2, 1, constant. Good. And then knock it out. 1, 5, 11, 50. No, I can tell already. 58. No. 290. No. 280. Fail. That's okay. It wasn't a fail. It was a near miss. Near miss. Lincoln, I thought you were lucky. Oh man, just disproven in math class.
-2.
-2? How did you know that?
What do you mean? What do you mean? How did I know this?
Oh, I thought you saw it here. It was erased, but you can still see it. You're lucky. That's what you're saying. We'll see.
Yeah.
1, -2, 4, -8, 5, -5, +10.
See, I told you. That's what I meant to say.
Yeah.
That's right.
He just got confused. It's okay.
Obviously, huh? Okay. So here's the deal. I know that -2 is a root. So if I express negative... Question?
I'm saying he's lucky.
All right. If -2 is a root, how am I going to express it in this expression then? X plus 2. X plus 2, because remember, find the roots and make it equal to 0. That would give us the root of -2. And then what's going to go here? It's going to be a trinomial Based on those three coefficients, what should I put? Squared. For x minus 5. Good. Now, I'd love it if I can finish this problem and get it all the way down to my three expressions. I know that x plus 2 is going to be in the mix because it's already binomial and done. How are we going to do this? Factor it. -5 and 4. How do we get there, Gene?
Oh,
You did it. There it is. Yes, that's it. And?
I have a question.
Okay.
So what if it was f of x is equal to 2x to the third plus 6x to the second plus
That-
3.
To the second plus 3.
3x plus minus 10. Basically the same problem except instead of having x to the third you have coefficient function.
Oh, that wouldn't be a big deal. That would change that to be a 2. That's all. That's
I was just wondering if that matters because that was 2 then you drop down to 2 and that means that
Yeah.
it would be 2x to the second plus
If that was a 2 up there, then -2 wouldn't work, likely. No, it wouldn't. So we'd have to find another one. So the a coefficient will impact which multiple we can use, which root we can try to find. I think that's a good question. But help me out here. It's going to be x plus 5, x minus 1. Answer. Sleepy? Too easy? Waiting for it to get hard? Not sure what's happening. Weird day. This is easy. I'm glad I get to do this last. Because really we're given three roots, -3, 1, and 2. We just have to express it as a polynomial. Okay. What am we going to start with? X plus 3 then. Minus 1. X minus 2. That's all equal to f of x. I really don't like on the right side, but we'll keep it there. Next, let's go ahead and factor this, or FOIL it. X squared plus 2x minus 3 and x minus 2. And then I wanted to show you one way that you can do this using, you can use a box method for this. Let's go do that for a second. 1, 2, 3, 1, 2, x squared, 2x, -3, x, -2. You see how I set that up? Because I want to multiply these together without having to do all that distribution. So we just have f of x is equal to those three expressions. Then we combine two of them with FOIL. We got this try, we got a by, so we have to multiply them together. Basically what you get in the box is combine terms, put it in order, you're done. Okay. You guys have seen box method like this before? No? You guys in genetics, you did the what are they called again? That's right. Everyone said it once. What is it? How do you spell it?
I don't know if it's 2N. It's 2N. It's a bit cute.
Not
Pundit.
No, not pundit. That's a different thing.
P-U-N-N-E.
Pundit. Okay, well that's what this is, basically. It's just like a multiplication table. So I'm going to go ahead and x times x squared, x to the third, 2x times x, 2x squared, -3 times x, and so on. -2x squared, -4x, +6. Any of these cancel out? Mm-hmm. Those do. So altogether, we figured out from the zeros, we were able to find the actual function we started with. The actual function was x to the third -7x plus 6. That's all we have to do for those type of problems. We're going to start with our roots and just work backwards. How are we feeling about this? Thumbs up, sideways, down for this whole lesson? Yeah. There's one that's shaking. Afraid. Or mostly I say the average is here. That's not bad. Okay, we have 8 problems to do. We have, wow, 29 minutes. Everyone does those. I'm going to stop you 3 minutes early, so you have 25 and change to finish that reflection survey. So Don't forget to subscribe. I haven't got a new subscriber in weeks.
Subscribe on 3.
Subscribe on 3. 1, 2, 3.
Subscribe!
Love it.